Hi, this is Alex from devstories.eu. Docker Masterclass, episode 17 of 18. An AI agent with the most advanced language model is practically useless for development if it cannot read your source code or execute your test suite. Without external capabilities, it just guesses at syntax. Agent toolsets and workflows solve this by bridging the gap between a simple text generator and a working software engineer. By default, a Docker agent runs in an isolated container. It has no idea what files exist in your project directory. To change this, you configure the toolsets array in your agent YAML file. Toolsets are pre-packaged capabilities that give the agent direct access to its host environment. For a development agent, you typically inject two primary toolsets: file system access and shell access. The file system toolset allows the agent to read your directory tree, open source files, and write code back to the disk. The shell toolset allows the agent to run terminal commands. Without the toolsets array, your agent is trapped in a box. With it, your agent has hands and eyes. However, giving an agent hands and eyes is a recipe for chaos if it lacks discipline. An unstructured agent might change a file, assume it worked, and report success without ever checking for syntax errors. You control this behavior using the instructions block in the YAML file. This block is not a place for vague suggestions. It is where you define a strict operational workflow. The most reliable way to structure these instructions is by breaking the agent tasks into 4 mandatory phases: analyze, examine, modify, and validate. You write these directly into the instructions block, telling the agent it must complete one phase before moving to the next. First is analyze. The agent reads the user prompt to understand the requested feature or bug fix. Next is examine. Here, you instruct the agent to use its file system toolset to search your codebase, find the relevant files, and read their contents to understand the current logic. Third is modify. The agent writes the updated code to the disk. This is the part that matters. The fourth phase is validate. This is where you force the agent to prove its work using the shell toolset. Consider an expert Go developer agent. In the validate section of your instructions, you explicitly mandate that the agent must run the command go test ... followed by golang ci-lint run. Because the agent has shell access, it executes those exact commands. If the Go compiler throws a syntax error, or if a test fails, the toolset feeds that terminal output directly back to the agent. Because your instructions state that the task is not complete until validation passes, the agent is forced to read the error, loop back to the modify phase, fix the code, and run the tests again. It will repeat this cycle until the linter is happy and the tests pass. Providing access to the file system and shell makes your agent capable of writing software, but structuring its instructions to demand explicit test execution makes your agent reliable. You bind its tools to a strict validation loop so you never have to review broken code. That is all for this one. Thanks for listening, and keep building.